Today's theme in the keynote session is sort of about where we go from here, and we always come to this session. And I have, as usual, we're going to have a patient and or family open the meeting to ground us about how important this work is. And it's not about technology and numbers. It's more about improving healthcare. So Gio and Tom, Tom is actually, like the other two families I'm blessed with, is one of my patients with a cardiac issue, and his dad is just as amazing because he actually is in this tech sector and has been always talking to me. Even at 1:30 this morning, he sent me a text about important development in AI, so I'm constantly inspired by not just him, but also his son. And his son did something quite amazing, and I'll let them tell you this story. So go ahead.
Yeah. So
let's use a microphone.
Oh yeah.
For a tech-savvy guy, he didn't pick up a microphone.
AV is not my specialty. Good morning. So my name is Gio, and thank you, Anthony, for having us up here. So first off, I want to say there's 4 ways that I'm related to Anthony. So first is FOA, which is friend of Anthony, and that is a thing, by the way. Most of you here are. The second one is POA, which is patient of Anthony, which is my younger son, 11-year-old George, who's sleeping. Otherwise, he'd be here upstairs. And then the new one, which is DOA, which is disciple of Anthony. That is what I'm terming it. And there's my wife, which is WTHIA, which is who the heck is Anthony? Right? For me, this journey has been extraordinary because, first of all, having my youngest son with a mitral valve leakage since birth, and Anthony's been his pediatric cardiologist for almost 10 years now. And so there's an inherent family interest there. And then I have to say, a couple of years ago, Tom may ask maybe 1 or 2 questions about work or what I do. I think after the summer, he asked me what I'm working on, who I'm working with, what this technology is. So it is incredible, this journey that I feel I'm going through that is discovery for me and everyone here. But I hope really that in this journey that I will learn from him in the coming future.
Hi, good morning, everyone. My name is Tom Merican. I'm currently a junior at Danborough High School. And obviously, like my dad said, my first exposure to AI in medicine was actually over the past summer, where I attended the MI3 summer internship at the Children's Hospital of Orange County, where Dr. Chang is one of the leaders of the program. And before that point in the summer, I confess that I had no idea of any of the impacts that AI is currently having on medicine and will have in the future. I was solely interested in the biology of the field. I've had my mind set on becoming a doctor from a young age. And after the internship, listening to multiple professionals from various fields of data science, nursing, medical research, I finally found something for me as sort of a hard truth, is that AI is the future, whether I liked it or not. But the internship was a really eye-opening experience for me and really motivated me to sort of absorb as much as I could about this emerging aspect of medicine for the future, what will enable me to become a different kind of doctor than the ones we see today. No offense to the physicians currently in the room. You guys are great.
Including one sitting on your left.
Yeah, exactly. But again, like my dad said, nowadays I'm constantly asking him, what he's been working on currently at work, because he's obviously one of my biggest inspirations and one of my biggest sources of information for what I feel like is now my future. And because of AI Med, because of the internship I joined, I can say with a complete certainty that I am 100% invested in what AI Med has for the future. So,
Tell us what you did at your school, though.
right. So, so because of all of that new information I learned over the course of the internship, I kind of realized how, at the start of the internship, how ignorant I have been of all of these new impacts AI was having on medicine. And I knew that all this new information I had learned was definitely going to be useful to some of my peers at my high school who are also looking into becoming doctors, nurses, data scientists, scientific researchers. And this information would not only be useful, but it's pretty much almost crucial to becoming those future professionals. So I took the effort to start AI Med Club at my high school. It successfully got passed 2 months ago, and starting in January, I'll actually be bringing in a guest speaker each month to talk about various basic concepts in AI to sort of broaden their understanding of how changes in the medical field are proceeding. And I'm taking the opportunity to invite all of you to come share your experience and knowledge at the school after the panel session. We can talk and we can arrange that. But I believe the AMAD Club at my high school is really sort of the start of something brand new, sort of launching kids like me into the future of AI in medicine.
Great. Can we give them a round of applause for a total self-starter, prime for Silicon Valley, so you guys should be worried, huh? Okay. Now it's just an amazing story about how this is more than just learning some application of AI in medicine, but it's actually about how do we salvage the doctors. They're really turning away from medicine right now. As you probably know, 75 to 80% of the doctors feel either stressed or burned out or not encouraging their younger generation colleagues and friends to go into the profession. So we're actually in more trouble than we think as a profession. And I think the nurses are not too far behind. Actually, they've done some stats on nurses, and they're just as professionally burned out. So we need some sort of renaissance and rejuvenation, and not to overplay or overreach AI in medicine, but certainly this is one of the ways we can perhaps transform medicine just to make it less burdensome for physicians that are in the field. So I thought that was an amazing story that he actually started something at his high school, and hopefully in other high schools and other children's hospitals will actually put a positive spin on what it's like to be a clinician rather than always talk about EHR and the big burden and burnout all the time, which for me gets very fatiguing and demoralizing. So wanted to put a positive spin, and thank you both for that. So have an amazing keynote session panel that's the powerhouses in Silicon Valley, and I'll introduce them briefly and they can talk more about what they do. In the middle is Jack Hittery, who's one of the very big names in Silicon Valley, venture capitalist, and has something exciting to share with us today about his passion right now. Jeff Rutledge is also a big name in Silicon Valley. We actually finally met him this year, even though we probably know about 100 plus people between us that it never crisscrossed. Again, one of the themes here is, despite the technology and everything talk about in AI, it's that human-to-human handshake and hug and personal touch that really makes a difference and move agendas forward. So totally encourage you to, if you're interested in the project, we talked lots in the last 3 days, go meet people, go shake their hands, spend some time in their domain to really move your agenda. And then at the end is Jack Poe, who's also a good friend and really an amazing force at Google, pushing the health side of Google and using his background in technology as well. So we'll start with Jack.
Anthony, for having me here today, and it's great to be here. Great. With all of you. I'm going to really spend my time focused on the oncology space. Our foundation is dedicated to medical research in oncology and specifically bringing new technologies into the oncology space. We support work at UCSF, at Sloan Kettering, at other institutions, and we're in the bunker, in the lab with the scientists, with the PIs, thinking through how do we actually get this done, how do we transition to using these technologies both in the lab and then actually getting it out to the clinic. I'll spend a few moments, I'm sure there's been a lot of great discussion the last few days in terms of the general applications of AI in medicine. It's always instructive for me to look at quotes like this. AI is timely, it's going to revolutionize and bring a lot of commercial applications. It's right here, right now. Herbert Shore said this. What year did he say this? Any guesses? I'll take some guesses starting in 1960, 1970. What do people think?
67.
Okay. Other guesses? Yeah. So 86 is when he said this. AI was definitely getting going at that time. I just finished speaking at an AI intensive where we trained about 100 engineers in the art and science of AI. And it's really interesting to see the arc of AI from 1943, McCulloch-Pitts, neurophysiologists who realized that we can be inspired by the neuron and understand that the basic understanding of basic mechanics of the neuron can inspire us to create this artificial neuron, to 1957, Frank Rosenblatt, who created the perceptron. And then 1969 comes, Minsky and Papert write the book Perceptron, which initially was going to praise it, but in the end ends up creating an AI winter when it says, this perceptron, this artificial neuron is not going to take us where we need to. And at that time, they just couldn't see that we'd have the compute, the data, and all the other platforms that we have today to actually get this done. So the connectionist architecture went into a winter for literally a decade and a half, popped up for a little bit, went into another winter, the second AI winter, and now, of course, we've emerged from that with a tremendous forest of activity. So always instructive, though, to see what people predict at different times. There has been an explosion of AI in healthcare, and even just, some of the names, I'm sure you've discussed some of the names here at this conference, but it's great to see, companies like Babylon in London now being adopted. There's about 700,000 individuals in the UK using Babylon as their primary care provider. That is, when they have symptoms, they no longer call a number of the NHS, the National Health Service of England. They actually use this app to triage what their symptoms are, and then either they can go to a physical doctor, or more likely what they do is they get a telemedicine doctor on the phone and able to communicate with that telemedicine doctor. That doctor can then prescribe various clinical tests that are needed. They go down the road to any one of the network of labs that they have in England, get those tests done. That pops into the app, and they go from there. So there's a lot of interesting stuff happening. They're about to get to 1.5 million citizens as well. Not to be left out, there's lots of other companies, Your.MD, Baidu, many other companies are in the space. We know about AI applied to drug development. Benevolent is, of course, one of the leaders there. Atomwise and others. Butterfly, an example of applying AI for the field. And so we have ultrasound. Ultrasound exists at CHOC, at many, at all the different institutions here. But when you go out to the field and you go to developing countries, it's not that easy to get the ultrasound, but it's even harder to get the ultrasound tech, the technician who can actually administer it, read it, and the clinician to understand what its implication is. So that's actually what this company is focused on. They're focused on taking the understanding of how to read that ultrasound, popping it into a small portable device, and then sending it out to the field. I should mention that I have no connection to any of the companies I'm discussing today. I have no investment in them, but I just want to really highlight all these different things. We know there's now 5 neural networks that have been approved and gotten FDA clearance as medical devices. The FDA is now aware of this. They have a set of people now who look at this area. Arcturus is one of those companies who takes an MRI and a special pulse sequence, is able to understand how to look at the heart and cardiac areas using MRI and now AI on top of it. But now let's kind of turn to oncology. So there's 5 areas I think that we can really focus on in terms of applying AI in the oncology scenario. First is in terms of when we think about novel targets and novel drugs. Checkpoint inhibitor has been a great story. It's been a great success story. We know about initially ipilimumab, and that's followed by Nivo, Pembro, which is the anti-PD-1s. You see here in this in this diagram. On the left, you have the T cell. On the right, you have the tumor cell. And basically what happens is our T cells have a certain receptor, in this case, the PD-1 receptor, and that receptor is there as a checkpoint. Why do we call it a checkpoint? Because if I get some pathogen in my body and I need to fight that, my immune system will start reacting, but I also equally need the ability to shut down my immune system, to calm that down. And so we have these checkpoints, and we have the ability in our own system to bring down the T cell and to put it into rest mode. Unfortunately, the tumor cell knows this, and the tumor cell has the ability, has that ligand, has that other chemical side of it to lock into that receptor and bring that T cell into a mode where it cannot act. And so that's what you see happening on the left panel. On the right panel, you see the drug. The drug is a antibody, not an antibody that we create in our bodies, but an antibody that's synthesized and then administered, usually once every 3 weeks, and is usually the protocol. And when the antibody is administered, you can see in this particular case, it locks into the receptor on the T cell and blocks the ability of PD-L1, the ligand, to get into that receptor. So we call that a checkpoint inhibitor. It inhibits the ability to lock into that checkpoint and shut down the T cell. This has been very, very effective. If you look at the mutation burden of all cancers, you can check that later online, you can see that melanoma has the highest mutation burden of all the cancers, followed by non-small cell lung cancer, followed by bladder cancer. And that's exactly the pathway of approval that we've seen with these kind of checkpoint inhibitors. So it was first approved in melanoma, then in non-small cell lung cancer, and then in bladder cancer right after that. And that's because when you have the ability for the cancer to get a rise out of the immune system, we call it being immunogenic, then the T cells are there, the soldiers are there. Unfortunately, without this drug, the T cells are shut down by the tumor. With this drug, the T cells are protected and they can go and attack. So the good news is we now have this drug, many lives are being saved. The bad news is not all lives are being saved. So in melanoma, to give you the numbers, in terms of durable response after 1 year, we're seeing about a 30-35% durable response. Now that is great. Stage 4 melanoma was essentially a death sentence before this drug. So it's great to see the 35% durable response. If you fail out of the durable response there, you go on to a combination of the new drug, the anti-PD-1, and the older drug, the CTLA-4, the ipilimumab drug. That combination is quite toxic to many people. And so 28% of the patients after 2 doses fail out of that due to toxicity because their immune system is now being so pumped up, they actually start attacking their own body. And so roughly speaking, we can save about 40% or so of folks with late-stage melanoma, but we still have 50-60% of folks to go. And so that leads to novel targets. And how do we figure out which combination? This is a very rich area of research. Unfortunately, the IDO trial earlier this year failed, and so when it read out, that is not going to go forward as an example. So that was one of the hopes, was IDO as a target. We have lots of other targets in the space, and we're funding research and looking at a lot of other potential combinations of targets. But which combination will work? And perhaps it's not just these combinations, but others as well. We can use AI, we can use machine learning to start to figure out these kind of combinations and accelerate our ability to get to a solution here. Let's now turn to genomics. Obviously, we know that cancer is a disease where mutation is the driver, the set of mutations. Often it's 1, 2, or 3 different mutations, sometimes 5 or 6 different mutations that all go off, and then you have the cancer. And so a lot of work is being done to really understand that. One of the hopes in the future is using CRISPR to start to get at the ability to get in and take care of that mutation. But we're far away from that, and one of the reasons is because of off-target sequencing, off-target cuts. And so when you have a sequence, the way that basically CRISPR works, I think most people here know about CRISPR, but the core way it works is just to illustrate here, you have 20 base pairs in your guide RNA. That's your template that you're trying to match into the DNA to find the site. And then it cuts on the 21st in that PAM region that you see over there. And so that's how it's supposed to work, and it does work. The problem is that the way nature evolved CRISPR is that it also will cut even when it's not exactly matching the 20 base pairs. So we now know that we can be up to 6 base pairs off, 6 mismatches in that guide RNA 20 base pair sequence, and it will still cut on the 21st. That's not good. It's okay right now because right now it's a fantastic research tool, and we use it in the lab to CRISPR up all kinds of novel mutations and to take out mutations and test all kinds of things. And at the University of Oregon Medical Center about a year ago now, they were also able to do it in a blastocyst. But until we handle this issue of the off-target cuts, this is going to be a mitigating factor, getting it from a research tool to a therapeutic tool. And so we're working on that right now, thinking about how we can use machine learning modeling to figure out when will this cut happen and when will this off-target cut not happen. And once we can model that and predict that and understand that, we can begin to mitigate that issue, and CRISPR may become a better tool. This is just an example of one of the articles written by a great team of scientists out there using machine learning to make this kind of prediction. So the work is happening right now. We're trying to encourage that to happen faster. Let me now turn to radiology and pathology. I started my career with images like this, and we actually then realized that the images were getting so complex, we needed to use neural networks to apply them to the brain images themselves. So we used a brain-inspired network to actually understand the brain images themselves. And what you see when you go into this is that the data is getting so complex, so rich, that you really need these kinds of neural networks, other kinds of machine learning to understand what's inside. Here, I'm co-registering, say, a PET scan on top of an MRI, so you get the great structural resolution of MRI, but then you get the activation of a PET scan as an example. And now we have functional MRI as well, and many other activities. Okay.
Hello, hello.
Great. Whoa. So this is an example where we definitely can use that, and that's already happening. The good news about radiology is that it comes out of the scanner already digital. So Philips and GE and Siemens and all the major manufacturers there have built systems now that it comes out digital. We can get the pixels. We can work on that. An area, though, that Anthony and I have talked about and others have talked about is pathology, and that's been much slower. 99% of all the slides, all the past slides in the United States of America have never been digitized. 99% have never been digitized. So someone gets a biopsy, it's sliced by a microtome, it's put on 7 to 8 slides, it's shown to a pathologist, pathologist reads it, writes a report. What happens to that slide? It goes into a cabinet and it stays there. And then the block, the rest of the biopsy, we call it a block, might be in paraffin, other ways of preserving it, goes also into that closet, and if we ever need to make more slides, we can go back to that block. So that's a rich source of data that is not available to us until we digitize. There are various efforts around the country right now to begin to digitize. There are 2 makers of a special scanner that scans in these kind of slides. You load up 300 to 400 at a time, you get them in, and then you can begin to do that. So one of the things that we're helping to fund is efforts around the country and hopefully around the world soon to begin to digitize all the past slides, particularly in oncology, so we can begin to understand the correlations and understanding between what the morphology of the pathology looks like in the slide and then what the clinical outcome is. And the good news is we can go retrospectively, right? So we can now scan the past 10 years, say, of different path slides that are out there and then correlate them with the clinical data we get from Epic or from other kinds of systems like that. So looking at that, lots of startups in that space as well. Let me now turn to subtractive medicine. 99% of the medicine that we have, the pharmacopoeia that we have out there today, is additive medicine. We're adding something to the body, and we hope that that thing will act in the way that we want it to, and will have more benefit than quote-unquote side effects. I always love that word, the side effect. And so this is a different way of thinking, though. And so instead of saying, okay, we're going to add something in, we're going to add a chemotherapy agent in, or add something in that we hope will do more benefit, more good than harm, this says maybe there are certain molecules in the body that if we subtract them out, just remove them, then a good process can move forward. a natural process can move forward. And this company, Nanotics, is an example of that. It's a startup up in the Bay Area that's focused on that, and they're demonstrating really, really interesting, good preclinical results, and I hope they get to clinic very soon. These are little nanots, little nanobots that go in. They'd have no arms and legs. They're not doing anything like that, but they're simply clamping on to a particular molecule that they have as a target. They're removing that within a few hours from the body, from the system, and then a natural process of the immune system can then move forward. And so this subtractive type of medicine is interesting, but we need machine learning to really figure out all the things there. And finally, I think more on the patient side, we can think about all the ways we can interact with patients, particularly as patients get older. They may not want to interact, say, with a screen, the ability to speak to a particular device out there, and the ability to talk to that device and say, hey, I need to make an appointment with my doctor. Can you make that appointment for me? And things like that, I think is quite strong. So I would just close saying that I think that AI in general healthcare is definitely beginning to have a very interesting impact. In oncology specifically, we really need these kinds of tools of machine learning. We really need these tools to think about in pathology, in analyzing all the stuff. There, the big burden right now is to digitize all that material. Thinking about it in radiology, where again, all the stuff is digitized right now, but now we need to kind of really understand how to use these tools. In genomics, not only in terms of the genomics that we have, everyone getting sequenced. The good news is most of the major cancer comprehensive centers are now sequencing many of the patients coming in, so we're getting more data. We have the Impact 500 at the UCSF. We have other 500 gene panels being used in other institutions. So the data set is beginning to be built. We can now apply machine learning to that, and then other areas of machine learning as well in drug development in oncology. So with that, thank you very much for having me. Thanks a lot.
Thank you. Wow. Amazing tour of AI in Silicon Valley. Jeff, you want to tell us what you're up to?
Well, good morning, everyone. I wanted to start by thanking and commending Anthony for putting together this amazing group of people who are so passionate about the applications of AI in healthcare. What I want to do this morning was expand on the conversation you started last evening when you asked the panel, what will the future of health be like? What will healthcare be like in the future? I wanted to particularly focus on primary or ambulatory care, the outpatient part of medicine. If you think about it, most of us don't end up in the hospital in a given year, but in fact, most of us spend have 2 or 3 visits with the doctor during the year and interact with and access the healthcare system as an outpatient. And what is that experience like? What is it like? What is the current state of healthcare? I would argue that accessing healthcare is really quite inconvenient. You need to call the office and physically travel to the doctor, usually, to get healthcare. It's incredibly expensive. We spend more than $500 billion in the U.S. alone on outpatient care each year. At the same time, it's wasteful. A lot of care delivered is actually not needed, and frankly, very expensive. So the cost of extra care that's needed and care that is not the ideal care given is actually a major part of the wastefulness of our system, making it inefficient. And frankly, we don't get the kind of outcomes that we really ought to get or should expect to get with the kind of effort and intensity of expense that we have in the healthcare system. So what I wanted to do was ask us collectively to think about what would the future of healthcare be? What will it be like when this future comes? The reality is that we have experienced transformation of how we access our lives in multiple sectors already. If you think about our ability to find information through the internet, the transportation experience, and particularly with Uber, think about commerce, and Amazon comes to mind there as the organization that's transformed how we access commercial transactions. And similarly, entertainment. We no longer go to Blockbuster when Netflix is there. So let's think about how healthcare can be and will be transformed. I'd argue that healthcare transformation is hard. I think we all know that. But it's inevitable. It will happen. And it will happen to address the needs. I wanted to focus now on the aspect of experiencing healthcare and what it is that needs to happen that will satisfy what it is that people want. So what is it that consumers want? As a patient, what would you like to have? And what should the healthcare journey be for someone that needs access to care? Well, I would argue that it starts with a health concern or a question, and that the people actually ought to be able to find trusted answers. When you go to a search engine today with a health query, you get lots of answers, but those answers may not be in context relevant to you, and more important, they may not come from a trusted source. So I would argue that in the future of health, it should be possible to get a trusted answer that is relevant to the person who's asking it. So the reliability and trustability of the result is really important. And then, of course, many people actually do need to get care, and that care should be easy to access. And it should be the right care. The right care at the right time and the right cost is possible in the future with a digital health platform. Similarly, the other side of the user experience, of course, is what the healthcare providers, in particular doctors, would like to do. And I would argue that the future of health will include solving the problem of what it is the doctors want too. And what do doctors want? Fundamentally, we go into this profession because we have a desire to help people. At the same time, it is our profession and we do need to make a living, but we're human beings. I'd like to comment that tragically, the problem with doctors is that they're human. People sometimes forget that. But doctors want to have fun and feel good about what they do, and I would argue that in the future, the systems will make it easier and more possible for doctors to actually enjoy their task. And coupled with that tightly, as Anthony was commenting, related to the healthcare provider burnout, doctors would like to spend less time doing administrative, clerical, and other tasks such as clinical documentation. And in the future, it will be possible for all of those tasks to be expedited for doctors. As you think about the kinds of care that will be that are needed in solving people's healthcare problems, many people, there's a funnel. There's a high volume of people's information needs and concerns and queries related to health that really don't require professional health care. If you think about it, we visit the doctor a couple of times a year, but the average person does between 10 and 20 searches, health-related searches on search engines on the internet. So our need for information is far greater, and this should be possible to deliver a personalized, in-context, trusted answer to people who have health questions right away. And that should be low cost and immediately available. Similarly, at the next step, people have concerns. They discover that they actually need a personalized attention and to get an answer from a question. It should be possible to get informational answers that are personalized to an individual from a professional easily and quickly without actually having to see that professional in person. Some people need to actually interact directly one-on-one with the doctor, and of course the ability to reach the right doctor and do a virtual consultation with that doctor should be possible. If you don't need to see the doctor in the office, why in heaven's earth, why in heaven would you want to go to the doctor's office if it was possible to interact? And in our current era, we expect to be able to do transactions and manage our lives on our devices, and why shouldn't you be able to immediately connect with the right doctor to get your healthcare problem solved straight away? Similarly, the doctor may discover, or you may interact and realize through the interaction of a healthcare system that you need to go and see the doctor. Well, which doctor, what kind of doctor, and with what urgency should be immediately part of how the interaction with the system gives you guidance to the right doctor at the right time. And this may, of course, also include a more urgent situation in which you need to see the emergency department. So this is really a diagrammatic representation of the different level of services, all of which should be given to people at the right time. And in the future, I can say that our healthcare system will make it easy for people to find the right care at the right time. Another way of looking at it is to look at the journey of what kinds of services and capabilities people should access. Starting in the lower right content, we talked about being able to search, finding questions answered, finding content to learn about things that you're interested in related to health. Asking a specific question that's related to you would be the next step. I would argue that the question answer should come ideally from a trusted source. We, for example, have asked doctors to directly answer questions that are informational in nature and have been quite successful in getting more than 100,000 doctors to actually answer such questions, building up a library that allows people to find an answer which is trusted from a source immediately online. The next step, and this is really where AI comes in, which is the idea that in the future, the system that you interact with will be intelligent and will be able to understand what the concerns are and actually take a next step level, which is use a knowledge-driven or AI-driven approach to understand, to collect information about you, and to give more guidance and advice built on an understanding of what the possible medical issues that you have are. At HealthTap, for example, we have a doctor AI service that does just that, a guided medical interview that creates a scenario which is all of the symptoms and associated risk factors that you have. The interesting thing in the future about such systems is that they'll be as smart as the doctor, even though they can't take responsibility for the final care. Giving a diagnosis online for free, I don't think is going to happen anytime soon. We talked about that yesterday, the need to have a responsible party, if you will, to actually take care. On the other hand, such systems can augment and support what doctors do. So that when you do see a doctor, moving around the circle here, when you do see a doctor, the doctor should have a leg up. The doctor can be given all of the information about you that you've shared with an AI-based system so that at the point of care, the doctor can focus on the things that only the doctor can do, which include, of course, caring about the patient, being empathetic, but also diving into the real-world issues that define the difference between a static patient scenario and the reality of what is involved for any individual person. The next step, of course, after you see the doctor is getting treatment, getting a recommendation online, if it's possible for that diagnosis to be made through a virtual visit. Then it should also be possible to deliver the care virtually so the doctor can immediately send prescriptions to the pharmacy and or arrange for other treatments. I think in the future we're going to see tremendous applications of AI. When care is delivered on a digital platform, it becomes possible to observe and learn from the care that's done. As a result of that, we will see over time much more applications of decision support and an understanding of what works and what doesn't. And I think the future of AI on the platform will very much center on what works and how to support. This is an area where we are really only seeing the very beginning efforts now. And of course, this is all tied together with the idea that your profile stored, any system that you're interacting with, should know about you. We've had real problems with integrating health information across multiple systems. Today, most people's care is disjointed. When you visit different providers, they don't know about each other. In the future, healthcare should include the opportunity for each person to have their own copy, their own record, and all of the healthcare interactions should be driven by an understanding of what you've already done. So in fact, what in the future, what we will see is that consumers will get the healthcare that they want, which is at this intersection of personalization, intelligent or AI-powered capabilities with crowdsourced expertise. At HealthTap, we've shown that this works by inviting doctors to participate with us. There's actually several in the audience today. I'd welcome you to interact if you are curious to understand why they do this, why doctors actually crowdsource their expertise in an effort to create a library of content and support people at a scale beyond what's possible to do in the office or one-on-one with patient interaction. So I would love to spend more time talking about the specifics of the doctor experience, because that's another side of how the application or support for the doctor care is a critical part of the future of AI, but I think we're running out of time here. So I wanted to comment that virtually everything I've talked about is actually already present and functioning on a platform that provides end-to-end care, starting with the question, going through the consult, and allowing for treatment. And so I'd like to say, to paraphrase what Anthony has said, the future is already here, it's just not yet evenly distributed. And I'll stop there.
Thank you.
As some of the folks on stage has already talked about, there are many, many applications of AI already happening, not just at Google, at Apple, at almost every facet of life at this point. These are some of the examples of products that we've really started to insert AI. In particular, we've used a lot of deep learning in a lot of these products. And I think some of the speakers have also talked a lot about Google, of course, touches many consumers today on things like search, on things like photos, on things like Gmail, etc. And many, many users actually also search health queries on Google today. Anywhere from 5 to 10% of the queries on Google today in the United States are actually health-related. Folks looking for information about symptoms, looking for information about what drugs they might want to take, what the side effects of those drugs might be. And for a long time, we've been told by the general press, by the physicians, that many of the results actually are medically dangerous, they come from untrusted sources. So we've actually been spending a lot of time in the last 2 years trying to figure out better ML and better AI so that we can reflect results that are more in line with what the traditional medical community expects. So for example, if you today search different symptoms on Google search, it will actually start to reflect information that are based on not just the query that you issued, but also on how likely you actually have a certain disease because the prevalence of that disease in the general population. You can actually try to search, for example, my baby is coughing at night potentially, and I will actually say that it is likely to be these 3 things, and if your baby is extremely severe, it might be this other thing. So we've actually already spent a lot of work trying to handle some of these queries in the last 2 years. One of the big things that a lot of folks are very excited about in ML and healthcare is in mental health. Mental health is one of the places where we know it's very underserved today, and a place where technology can actually do a lot of good directly. And we've also done a lot of work on the Google search engine specifically around mental health. So if you were to, for example, search queries that indicate that a patient might be looking for help or that they might be potentially committing self-harm, we actually detect that and we start to give information to the user about where they might be able to get help. And this is actually not just us. This was a big collaboration between us and Facebook and Apple and other tech companies where all of us realize that we touch consumers in a very intimate way. We have the ability to know when users are starting to get into trouble. And if the consumers opt into an experience, we would like to help them by giving them information that they might be looking for when they're looking for help, when they're looking for not just help in mental health, but maybe things like poison control. And actually we have a very successful program around sex trafficking when we detect users are potentially being sex trafficked or looking for help on Google. So there are lots of applications on the consumer side where a lot of ML is actually being quietly inserted into various products across the tech companies where we think they can already be of assistance to consumer health. There are other technologies in which there are more research-based, and I think more of the things that various folks have talked about in the last few days. I'll just quickly mention a few that we're actually working on inside of Google. These are not on the consumer side. Probably unsurprisingly, given that Jack is at Alphabet, that many of the projects that we're working on lines up with some of the things that he is very excited about and many of us are excited about. One of which is, of course, diagnostics. There are many companies and many folks, even on this stage, who've talked about the different things that you can do in medical imaging that ideally machine learning can do quite well. There's actually quite a few examples, not just from Google, from many companies at this point, actually including Facebook, who've started to do radiology at NYU, of machine learning algorithms performing just as well, if not potentially better than physicians in many use cases. And I think this is what's exciting a lot of physicians, a lot of pharma companies about what it can do. We've since moved on from just looking at things that physicians today diagnosed, and we've tried to see are there other things that you can pull out from these medical images that physicians today do not actually look at. So some of this is a proof of principle. This paper actually is now in Nature as opposed to Archive. But can you, for example, pull out the age and gender of a patient from a retinal image? Not something that a physician normally look for today, but these are things that ideally, if there's a lot of signal in the image, you might be able to pull out. It might mean that if this is possible, you might be able to pull out cancer biomarkers or other types of cardiovascular risks, etc. And this is actually exactly what we found. We can actually seem to pull out things like cardiovascular risk, stroke risk, etc. from the retinal images themselves. This is something that physicians today generally don't know how to look for in the images. Another part of what's really interesting with a lot of these machine learning techniques is what does it mean to even pull out these things, right? Physicians really dislike black boxes, and it also doesn't really help if for figuring out new treatments, as Jack was suggesting. So a lot of work has been ongoing at both DeepMind and at Google, and actually across the field, on generating insight on what these models are actually picking up. And for example, some of these red lines that might be hard to see are what the machine learning algorithm thinks is important in that particular prediction. So If you are armed with that information, you can give the physician that information and say, the machine learning model seems to think that cardiovascular risk is much higher in this patient because of these things. And now there are two things that are very helpful as a result. It gives physicians a way to actually use that information as opposed to just giving them a 0.9 risk score. And the second part is it actually allows researchers to start using that information to think of new pathophysiology or potentially investigate new pathophysiology on how we might be able to target some of the things that are lighting up to figure out new treatments. This is another example, actually not in medical imaging. This is an example of an EEG where we can actually also do similar type of work. You can do deep learning, but you can also do what we call interpretation, where it's actually lighting up parts of the brain waves on what the computer model seems to think indicates this person is having a seizure. And you can actually localize it down to which channel, as well as in what time the models are actually recognizing this. And all of these right now are dependent on a lot of data. And this is something that the field is spending a lot of time working on. One of the things that we found, and I think many folks have talked about, is that physicians routinely disagree about diagnosis. And a lot of these machine learning models are very, very heavily dependent on having very good ground truth data for both training and for testing. There's been a lot of work in the last few years trying to bring down the number of examples you need so that a good model can be built, but we're still in the order of tens of thousands in order to build a good model. The problem with that is we can build great one-off models, but at some point, let's say you want to look at an X-ray, a physician looks at something like 400, 500 conditions when they scan an X-ray. It is, at this point, not completely realistic to build 500 different models, each of which requires tens of thousands of images, especially when some of these conditions are extremely rare. So the field is spending a lot of time trying to figure out how do we actually get ground truth? Is it really possible to learn from much noisier data than what we have today? I will skip through some of these fairly quickly. I think there are a lot of folks working on this, but this is an example of a different type of data, learning directly from the electronic health record. And the innovation here is lots of EHR data right today are in basically all types of different formats, and it's very hard to aggregate large amounts of them, even when you have access to the digital data. So a lot of work has been done to figure out how to aggregate lots and lots of different data. And then if you were to build models, very similar to what I was discussing earlier, how do you actually interpret some of the results? Out of all that data, if you say a patient has a mortality score of 0.9, what does that mean and how do I deal with this patient? So we've started to build models that, for example, here, you can actually see we will flag out specific sections of the medical record and say these are the reasons why we think this patient has a specifically high mortality score. There are multiple reasons why this is important, one of which is for physicians, and a second of which is actually just to figure out if your model even makes sense. Early on in the process of building these models, we actually built several mortality models that had a perfect predictability score. In general, if you're machine learning, if you build a perfect model, you probably did something wrong. So we went back and we tried to figure out what was actually happening with these models, and we couldn't really figure it out until we built these models. And what was happening was, it turns out, and many of the physicians here will know, in the ICUs, when you think a patient is not doing well, you ask for a priest consult. So the priest will go and see the patient. And the model picked up on it and realized, basically, the priest is killing all the patients. It, of course, is not what's actually happening, but the ability to inspect these models is what will allow us to figure out what things are actually going to be helpful, even though the predictive power might be very high, versus what things physicians today already know, and their decision-making just happens to be embedded in the data already. One of the things that is very hard to figure out, as I suggested, is this problem between correlation and causation. And there's a lot of work currently being done to try to see if some of these new machine learning models can actually figure out causation versus purely correlation. The other thing I will very quickly skim past, because Jack already talked a lot about this, is looking at personalized medicine, specifically around things like genomics and protein folding. it turns out that, especially around things like genomics, where compared to the rest of medicine, the amount of data is enormous, which is actually enormously helpful for things like deep learning. Very simple techniques in deep learning can start to generate really, really good results. One of the things that Google worked on in the last few years is a thing called deep variant, where basically we put a very simple deep learning hack, which is if you're not really sure how to deal with a deep learning problem, you convert it to an image, and you take the image and you just power it into TensorFlow and hope that it works, and it turns out it works. So we literally just took a bunch of genetic signal, mapped the different nucleic acids into different colors, and hope that it works, and it actually works really, really well. To the point where it was beating many of the actually it beat, well, depending on who you talk to, either all or most of the genetic algorithms specifically to figure out where different mismatches might be happening today. The other thing that I'll briefly mention is, of course, this is a very simple technique. There are other techniques, for example, that came out in the last few days, which you can do much more advanced things with not a lot of data. This is an example of protein folding being done using deep learning, actually recently out of DeepMind, where the performance was significantly better than the second place winner, and it was very much done in a similar way, but not just to images. So there are many, many exciting opportunities where we're applying different types of machine learning techniques and starting to see very interesting gains. So I'll stop here, but thank you so much for inviting me here.
Thank you. Just an amazing amount of material in such a short time. I just realized sitting here that I had the special privilege of visiting all three of you this past year. And what I liked best about the visits is just spending some time with you human to human, talking and crafting a vision for medical care in the future. And what I liked about each of you is, despite all the technology and sophistication of it now, you have your feet on the ground and you realize that things need to be done. So one of the questions I asked our keynote session panelists yesterday is, you're in Silicon Valley, all three of you, and you have just ongoing barrage of technologies thrown at you. At the same time, we can't even do very basic things well, like getting patients to come see you in the clinic, compliance with medications, mental health aspects is just not even really seriously tapped into. So how do you balance the two divergent sort of trends in healthcare?
A great question. Great question, Anthony. I'd argue that certainly the perspective we've taken at HealthTap is one of creating a solution. We created the company as a direct-to-consumer company rather than as a for doctors or for healthcare system, with the understanding that creating an environment, an application, a service that people wanted to use was a critical first step, and that bringing people to a application, a service that actually helped address those needs, as I talked about what it is that people want, that systematically giving people a place where they could go to get, in this case, an answer to their question as a first step in identifying what help they needed to move forward. So fundamentally, I think the answer to your question is creating systems that actually directly address the needs that people have at the point of that need.
I would just add, is this working now? Yes. Yeah, okay. I would just add that the first irony, Anthony, is that in this age of digital, we're supposed to be all just televideoing around and things like that. I've been traveling more than I've ever traveled before to be at conferences like this, to be with you, to be here in person. Everyone here has traveled here.
Are we sure you're here in person?
Yeah, that's a good question. That's a good question. I have actually already done one hologram speech.
Have you?
Yes,
okay.
Where I had to beam in as a hologram, and so apparently it went well. We'll see. But so that's the first irony, that we still value the in-person contact. We still value very much being there, and obviously in healthcare, that's super critical as well. I think when you look at some of the technologies that are coming out, one test I always have when I look at a technology is from a behavioral modification point of view, from the workflow, the daily life flow of that patient and or doctor. Is a change needed, or is it embedded in the life flow. That binary choice in terms of, does it represent something that they now have to veer off in another direction, or can they just incorporate it into their current workflow or life flow? That to me is always a big litmus test. So I'll give you an example back to pathology. There are several initiatives right now to say to pathologists, okay, not only are we going to scan the slide, those microtomes cuts that I just mentioned before, but we're actually going to display it to you on a super high resolution screen. And instead of using a microscope, we want you to use this screen and a mouse and a cursor to identify your regions of interest and to go down that way. Now, from a digital internet machine learning perspective, that makes a lot of sense, right? It's like, oh, it could be digital. We can do all kinds of funky things with it. And that turns out to be the wrong answer. That turns out to be the wrong answer. Pathologists today have a workflow. They have their setup. They're usually their Olympus. There's one standard microscope that 90% of them use. They often have an assistant right here. A slide is put in. They read out what they want to read. Next slide is popped in, and they have an entire workflow. The digital version of that workflow is actually slower, not faster. What we want to do with digital in this case is not replace the current workflow and take out the Olympus microscope, leave it there. What we want is an additional screen and input that comes from the machine learning model that says, I, machine learning model, have looked at 700,000 patients, biopsies and slide scans, and I've correlated with the electronic medical record that Jack was talking about, the EMR, EHR, say from Epic or others. I've done all that. Based on that, I think in slide 2 of this 8-slide stack, I'm seeing this morphology. Sometimes we call it in pathology spindling, when kind of like imagine a cell goes on a diet and kind of gets very thin. That's one of the indicators, let's say, for example, of melanoma. I see some spindling. And we know that we have a certain error rate, that we have a certain human error rate in pathology. So we can suggest to the pathologist on this screen over here, while they're looking in the microscope, can you check out upper quadrant, left quadrant of slide number 2, check that out.
So
And
real
that kind
time,
of,
like a GPS.
yeah, so it's kind of like human, we say HPM, human partners with machines. Let's get the human and the machine kind of working together. So I think that's one of the visions that we see happening.
So Jack, how do you reconcile this?
Yeah, I think I
Almost
totally
dichotomy,
agree
yeah.
with the points that were made. This is not a problem that was unique to AI. Prior to working at AI, I spent a lot of time building medical devices. And the same problem existed in medical devices. There were lots of things where if you broke the workflow of physicians, it really doesn't matter if you were much more accurate. Nobody was simply going to use them. Physician spends decades training on how to do a specific type of surgery, how to put a very thin wire down a specific part of the heart. They're not going to suddenly drop 20 years of training and use a ultrasound guided blank. And I think it's very important, especially for the younger generation of soon-to-be physicians who are coming up, to help us make that transition where a lot of us are, in good or in bad ways, set in our old ways of doing medicine, but are open to certain techniques to help bridge that gap. And a lot of us are working on exactly what Jack mentioned. How do you use ML in a way that currently works in workflow, but slowly help to bridge that gap to move to a place where a lot of the AI ML is really sort of directly in front of the physician as opposed to just an assistant piece where it's just guided from the background.
If I could double down on that, I think it's a really wonderful example of how true this is, that you need to be in the workflow and supporting the actual process that goes on. If you look at the history of AI in medicine, for example, we 20 years ago created systems that you could consult with, that were designed for doctors to consult with to get a better answer.
The expert systems.
And they were a complete failure because they required a workflow that was different. And today we're in this wonderful place. I hinted at some of it with where we're going with this, when what we're actually already doing already, which is at the point of care, if you can take the task the doctor's already doing and make it faster and easier and provide support. So for example, if you can do the routine parts of a medical interview and write the note for the doctor before the patient comes in, allowing the doctor to focus on that. And because it's an AI solution, that system can also provide the doctor decision support. Hey doc, don't forget to think about, here's the top rated things that are likely explanations for all the things the patients told me even before you saw them, so that you can reduce the amount of time it takes for the doctor, let the doctor focus on the things that they're best at, and speed the process so that
addressing issues related to burnout and better care.
I'm going to ask 2 questions, short answers this time because we're closing up. What's your best offer from your portfolio of available technologies for global health? Because we didn't cover global health this time. We're planning on it next year. Global health, something that we all should be conscious of. What do you think is your best tool that you can offer in your portfolio for global health?
Oh, that's a big question. Go ahead, John.
I can take a start, since it was one of the missions of our company to help people in any way that was possible to do for free, if you will. I invited doctors to participate answering questions and putting those answers into a library that was then available for free on the internet. So we've now got multiple millions of answers. We have the doctors peer review the answers so you can tell which are the good ones. And we make that available for free around the world. And more than 137 countries, people have accessed hundreds of millions of times the information for free. But this idea that there ought to be a global resource of everything that's possible to do in an automated way available to anybody, anywhere, for free. And there's some substantial progress there already.
Then Jax?
I'll answer in a slightly cheeky way, which is, I think Android. I think there's actually a lot of technology that is not what you call quote unquote healthcare technology that is impacting health in a very large way, and the ability for people to communicate very quickly, whether it's for physicians or just with each other, I think it is already transforming healthcare today. And between Android and self-driving car, I think it's going to very significantly change the health burden.
Anthony, I would point to what I would call embedded ML at point of care. What I mean by that is I showed Butterfly as one example where, again, getting ultrasound to be super portable, GE's worked on that, many have worked on that. We have now portable, cheaper ultrasound, but getting the read, that is the technician, inside that same device, right, on a portable point of care field solution that does not have to be connected to the internet, that does not assume any Wi-Fi or any other kind of mesh wireless around. That is something that's revolutionary. I'd like to see that start to happen, Anthony, now across the board in various kinds of imaging modalities and also other biomarker modalities where you'd have a machine, right, that takes the blood, spins it, looks at it, and then is able to do some basic analysis at the point of care in a field hospital where we don't have that infrastructure.
Yeah, great. And one last question, short answers also. We have an amazing young person here that's thinking about medicine as well as technology and AI. Words of advice or wisdom from all three of you?
Tom, I would say to you what I said actually to a few other budding medical students and current medical students, because they do come to us for advice. First, I think that we need to rethink the medical curriculum. We're talking to a number of universities now about that. I've already sent 3 medical students to 90-day coding boot camps, not because I want them to become coders, and that's going to be your new career of coding all day, but knowing how the insides work to this thing. And the great news is it's never been a better time to learn about this stuff. Back in the old day, i.e. 5 years ago, you'd have to, kind of go through all kinds of machinations to learn what's going on. Today, with the tools that are so much better in terms of understanding how to get code out, debugging code, looking at code, sharing of code, GitHub, all kinds of other platforms to share code. This is a great moment, and we're talking to a number of medical schools about how can we incorporate this into the actual curriculum so that when the doctor comes out newly minted, they've got a deep understanding of the behind the scenes, who's the wizard behind the curtain.
I think as I was telling my program director on my way out, that I actually changed my way of thinking as a physician.
Yeah.
Not just applying technology, but the way you approach a problem, much more patient with the other side of the brain than I used to be. Jeff?
Well, I'd agree that we need an advancement and update, if you will, of the medical curriculum. I would point out that there's really 2 sides to this. One is an understanding of what the limitations and functionality of the technology is, and the other really should be, in my opinion, a renewed emphasis on what it is that makes physicians doctors, physicians, right? What it is that is required to actually do the things that are uniquely human for a doctor. And the combination of understanding the role of the physician in caring for the patient needs to be coupled with an understanding of how to use the technology, what the strengths are, what it's good for, and how it benefits and supports all of the things that the doctor needs to do.
Jack, especially relevant to you now.
I think I agree with everything that's said. Even on the federal level, there is a lot of effort right now to see what we could do about the medical boards, because we realize even outside of AI, physicians do not have up-to-date information about even things like statistics, and are getting, doing a lot of things that might not make sense. So I would say you do not need to be a biostatistician, like what Jack mentioned. You do not need to be a coder, but it's helpful to understand enough so that you can really understand what the extent and what the limitations are.
So Tom, I'm going to give you the last word, because you are the future, literally. So what do you think you could impart on all of us to understand the future?
Okay, so listening to all these talks again has been a great experience for me, and as my final words on this panel, I think that when I look at my friends and my colleagues throughout my high school, working so hard as high school is getting more competitive, looking toward the future and getting into colleges, older friends looking to get into medical school, problems like revamping the curriculum, problems in ethics in regards to AI, all sorts of issues are going to be arising with this new emergence of AI in medicine. And obviously that's a result of what I see as this is a new frontier. This is really a huge innovation in what medicine is as a field. I think that with the emergence of AI, this is within the next decade, I see a new type of healthcare. As in 10 years, actually, I see that what we're currently discussing as AI will not be as highly discussed in 10 years, because I believe in 10 years, AI will become something as normal and important for a doctor to have as a stethoscope around his neck. And I believe that in 10 years, it'll be more of a question of, instead of how AI can improve healthcare, it'll be more of a question how AI will elevate healthcare to more of wellness care, more on a global scale, and really taking it to solve those bigger issues around the world. And that's something that I personally really look forward to in the coming years as I continue on my journey. And I thank you guys again for sharing your info. I've learned a lot, and I'll be definitely taking this forward as I continue working with my AA Med Club and pursuing my path to hopefully becoming a successful future doctor that I hope to be. So, thank you.